I will present our first presenter, Brian O'Neill, and then I will introduce Cecilia Conte, who's the second presenter. Brian O'Neill is the main researcher in the group of integral evaluation of the National Center for Atmospheric Research. He has a PhD and an MA of the New York University. His research areas are in the area of modeling climate change that links together socioeconomic and natural science elements in order to respond to research questions that are germane to public policies. His areas of research interest are concentrated in examining, on the one hand, the relationship between the socioeconomic development trajectories, emissions, and climate change impact, and on the other hand, in the analysis of scenarios linked to long-term climate change and short-term sessions. Brian O'Neill is the main author, together with Landy Sánchez and Wolfgang Lutz, of the widely known text published in 2005. It has many articles that examines the relationship between the environment and demographic change. He's also been a leader author of the 4th and 5th reports of the Intergovernmental Panel for Climate Change. Without much ado, we give the floor to Brian, and then we will hear Cecilia Conde's presentation.
Okay, thanks very much, Landy, for that kind introduction. Just let me know if at any point you can't hear me anymore or something goes wrong. I want to thank the organizers of this meeting for inviting me to participate, and especially Landy Sánchez. I'm sorry I can't be there. I'd prefer to be in the room with you, and sorry to leave a blank or an empty chair behind my name card on the front desk there. But thanks to the technicians on either side of the line here, we have a good connection, and I'm happy to be participating remotely. So as Landy said, I am going to be talking about a research framework for climate change and relating it in the end to some possible needs for data and other kinds of information related principally to demography and socioeconomic variables as opposed to physical variables. So this research framework is what the title refers to here as the new scenario process for climate change research. And this is a research effort for developing this framework that I've been involved in, but it's a much larger effort. It involves many institutions across many countries. It's been going on for several years. We're fairly far along in developing the framework, but it's actually not quite completely done yet, as you'll see. So it is an evolving effort, and it seems like relevant to considerations like the ones you are taking up in this meeting, because with luck, if this framework is found to be useful, it may inform a lot of different kinds of research across many fields for quite a few years into the future. I thought maybe a good place to start is just make sure we're all on the same page about what we're talking about when we say scenario. People have different levels of experience with scenarios and what they call them and how they use them. So what we're going to be referring to here in this particular scenario process is plausible descriptions of the future, and in particular the evolution of both the climate system and society. So we're particularly interested in future scenarios that involve both societal change and climate change. And of course, you can have scenarios of one, the other, you can have scenarios of other issues. That's what we'll be talking about here. And also these scenarios include both qualitative parts and quantitative parts. And when we say scenario, we mean both of those things together. So when we're describing a plausible future, part of that description is text. It's a story, it's a narrative, it's a few pages of description of how the world may unfold. And part of it is some quantification of some of those elements, not just describing in text how fast population may grow or technology may evolve or what the energy system may look like, but actually quantifying that and do model-based projections to provide a little more concreteness to these descriptions. And why do we want to do this in the first place? And again, the idea here is that this research effort is not to develop a scenario for a particular research project and then you use it, you do your research, you write your paper, and you're done, but rather to develop a set of scenarios that can provide a framework to support a wide range of research. And there's a few reasons for doing that. One is to facilitate the research itself. If everyone who was doing a study of potential future climate change conditions and their consequences or drivers, and each of those people to develop their own scenario, it'd be a lot of work and a lot of redundancy. So in this way, you can provide a kind of common good, a public good to the research world that would improve efficiency. You have one effort to produce a set of scenarios, then lots of people can use them without having to produce them themselves. The other is that there's really, in doing this, a strong eye toward assessment. It's looking farther down the road, whether it's 6 or 7 years from now and the Intergovernmental Panel on Climate Change, which Landy referred to, is doing the assessment, or it may be a national body that's doing an assessment or so on. From years now, or a couple decades now of sometimes painful experience, we know that assessment is really hard to do if all of the research papers that are out there in the world make different assumptions about future population, future economic growth, and so on. It's very difficult to then compare the conclusions. If you get a conclusion for a certain kind of impact on agriculture or on coastal storm impacts or so on, and say you've got 10 papers that have different kinds of results, and you try to draw some conclusion, you don't know why those results differ. If they're all making different assumptions about future climate, the future state of society, the level of poverty, and so on, you don't know why your impact results are.
We are back.
Okay, good. So third is exploring uncertainty, is that we want to create the framework in such a way that the scenarios that we're using are spanning the important ranges of uncertainty. As Landy referred to in her introduction, there's a lot we know about climate change. There are strong conclusions already. There are also important uncertainties. And so in order for research to effectively investigate those uncertainties, you have to have the framework set up to actually span them. Are we most interested in uncertainty in climate? Are we interested in uncertainty in societal evolution? In what aspects of societal evolution? We want to take that into account at the beginning. Okay, so moving on then to the scenario framework itself. The framework has been referred to by a couple of different names, but the process of actually producing it for a long time has been referred to as the parallel process. And that's simply because the work for producing these scenarios has been split in two, and the two types of work have been going on at the same time, primarily to save time, so that one type of work doesn't have to wait for the other. So it starts with specifying future pathways of what the atmospheric concentration of greenhouse gases might look like.
Brian, I'm sorry, can you
yeah.
put your presentation on the screen?
Okay, so back to the parallel process. So this is the process by which these scenarios are being developed. And the two halves of the project involve producing future climate outcomes and future societal outcomes, and then bringing them together into integrated scenarios that include both climate change and societal change. Just a little bit of jargon. We'll try to keep it to a minimum. But the way this is working is starting with what are called the representative concentration pathways. So these are 4 different possible pathways of atmospheric concentrations of greenhouse gases. It's fairly straightforward. There's a pathway which has high growth in greenhouse gas concentrations, one with very low growth, and a couple in the middle. And those are called the RCPs, or representative concentration pathways. And then at the same time, on one branch to the right, climate models, 20 or 30 climate modeling groups around the world have run their climate models to see what would the climate consequences of those concentrations be. And at the same time, on the other side of the screen, has been a parallel effort to develop future societal pathways. And these are called, again, some jargon, shared socioeconomic pathways, or SSPs. And these are a small number, as we'll see. We ended up developing 5 different ways that society may evolve, some more pessimistic, some more optimistic, into the future. And they're designed in a way that they can be, by combining them with assumptions about how much emissions of greenhouse gases might be reduced within any of those worlds, that they can be made to match the concentrations of greenhouse gases in the atmosphere that are specified in the RCPs. So in the end, you can bring these together in some consistent framework. Different future societies that may experience different future climate change. So if we can go to the next slide. Yep, so we have to go back. Yeah. Right. Yeah, so just as an illustration of where we are, all of the climate model simulations have been done. They are complete. They're all available publicly for use. What I'm showing here is just one variable from those runs, which is global average temperature change according to these 4 different concentration pathways. You see there's number 1, a wide range of warming covered, anything from about 1 additional degree of warming relative to today to 4 or 5 relative to today over the next century. There's a range of uncertainty for any given concentration pathway, and that uncertainty comes from the different climate models that are being used. So that's climate uncertainty, and also scenario uncertainty in the sense of pathways of how high greenhouse gas concentrations may increase or not. But what we want to focus on most today is not the climate side, but the societal side. So if we go to the next slide, then we start talking about the shared socioeconomic pathways. So first, what are they? So you can go ahead and forward through the next couple things just to fill up the slide with its content. Right, thank you. So at the top we see, again, going back to the idea that these pathways have both a qualitative and a quantitative component. So the SSPs have, for each one, there are narratives, so several pages of text, and that text describes in broad terms the general pattern of development that is envisioned under this pathway. And also the logic to it of why in this pathway does population proceed in a particular manner while economy is proceeding in another manner, and technology and so on. What is it that's actually causing them to relate to each other in a particular way? And then there are several elements that have been quantified. So each of these SSPs has country-specific global projections for population, education, so educational attainment of each country, urbanization, income in terms of GDP, and currently there are efforts underway to go beyond those basic variables to provide spatial projections of the population and income distributions within country for each of these SSPs. Now, just a couple notes on these is these are not yet the integrated scenarios we're looking for, right? That comes later. These are societal development pathways. So they don't yet have any assumptions about climate policy in them. They don't have climate change effects in them, right? These are things that come later when we integrate things together with climate outcomes, and then we take those into account. And they don't yet include emissions or land use outcomes. They're the societal component. That's what the SSPs are. So if we go to the next slide, and again, you can fill that in. What we want to say next is, okay, so as we can all imagine, there is an infinite number of futures that we could imagine the world taking in the future. We can't consider an infinite number of them when we do climate research. We can manage a small number. So which ones should we take? How do we know we have a set that's going to work well for us? And the idea here is of this slide is that the conceptual framework that was settled on was one to say, okay, what uncertainties are we primarily interested in? These are scenarios aimed at climate change research, and therefore what we're interested in is futures that can help us understand how difficult or easy it might be to respond to climate change. And in general, we have two kinds of responses: mitigation or emissions reduction responses, or adaptation responses. Those are things that we want to study in the end. And therefore, we want development pathways that span a range of worlds in which the elements of society, whether it's demographic, economic, governance, policy, technology, make it hard to adapt or easy to adapt, or hard to mitigate or easy to mitigate. We want to span that range. So to span that range, we make two axes and say, well, let's develop an SSP for each of the primary spaces within this uncertainty area. So that's why 5 SSPs were settled on. 4 of them, the ones, leaving out the middle, were ones in which one of these challenges to society was high, all the different combinations of high or low challenges to either mitigation or adaptation. So for example, in the bottom left, SSP1, the sustainability scenario is one. It's an optimistic development pathway. Challenges both to mitigation and to adaptation are low. In contrast, in the upper right, SSP3 is a storyline about fragmentation and regional rivalry, is a scenario, a storyline for the future in which it's anticipated that would make a difficult world in which to respond to climate change. 5 and 4 are ones in which one challenge dominates. It's, say, hard to mitigate, but maybe not so hard to adapt, and vice versa. And the one in the middle is called middle of the road because that's what the idea was. It sort of medium challenges to everything. So that's why there are 5, and that's the goal for developing these, is we want scenarios that in the end cover this uncertainty range. So if we go to the next slide, we have just an example of the introduction to one of the narratives, just to give a little flavor of what one of these SSPs looks like. So as we saw from the previous slide, SSP3, that's a pessimistic world, high challenges to adaptation and mitigation. The basic storyline here is this is a world in which different regions of the world have a growing interest in their own identity, have concerns with security and competitiveness. So it's an inward-looking world in which globalization does not proceed as fast and in some cases reverses. Global institutions are weak. There's not a lot of cooperation across regions. There are barriers to trade, including in energy and agriculture. Development goals do not, the priority for development goals is reduced relative to concerns about security, including energy and food security. Population growth ends up fairly high. Economic growth is fairly low. Technological progress is slow. All of these things combine to make it difficult to mitigate. We don't really have level of global cooperation or technological development to make it easy to reduce emissions. And then the slow economic growth, low institutional capacity, and lack of attention to development goals makes it also hard to adapt in this world. So that gives you a sense of the kind of considerations that went into producing these. If we go to the next slide, we have just a summary of where do things stand. And again, we can fill in that slide. Right now, for the SSPs, the conceptual framework that I described has been completed, papers written and published. There is a special issue of Climatic Change that's available. The qualitative components of the SSPs are completed, have been accepted. They're actually available online as part of a special issue of Global Environmental Change that is still in the works, but a few papers are available. The quantification of drivers has been completed, so population, education, urbanization, GDP, those are all done. They're available on a website at an institution in Austria, IASA. Papers will be coming out soon. We then want to turn to thinking about combining these, right? In the end, the idea is to bring together climate futures with societal futures. That's the end goal, to then provide integrated scenarios where we actually do studies with these, right? So far, this is just the framework. So if we go to the next slide, this is just a conceptual sketch of how do we bring these together. And the idea is fairly straightforward, right? We have 5 SSPs, societal futures. We have 4 climate futures. And so we make a matrix. The columns are our different societal futures. The rows are our different climate futures. These numbers, radiative forcing level, the 8.5, 6.0, and so on. That's just the jargon for naming the different climate futures. They're named according to the concentration or radiative forcing level they reach by the end of the century. So the top row there is the high one, the bottom row is the low one, and so on. Each of these white boxes just indicates a combination of a particular societal future and a particular climate future. So the arrows that you see, for example, now are using the example of, suppose we wanted to do a study that said, under this pessimistic development pathway, SSP 3, let's suppose climate ends up with a medium range outcome. How would we do that? Well, we have the narratives and quantitative driver information from the SSP 3. We would bring that to bear. Then, and it's a little hard to see, but I think if you advance the slide a little bit further, you will see another arrow or two. No, I guess you have it up there. So that's fine. So then we would draw on the climate information from the climate simulations that have been done for the medium concentration level, and you would bring those together and do your study. That may be either producing an integrated scenario, doing an analysis of what it would take in that world to reduce emissions to achieve that outcome. You may be carrying out a local or regional or global impact study where you need societal information and climate information, whatever it may be. And the goal is, in the end, each of these boxes would get filled up with studies at different scales, different sectors, different kinds. And down the road, 5, 6, 7 years from now, we should then be in a much better position to assess research in a way where we can make more comparable comparisons across studies that, for example, share the same climate outcome, but look at how adaptation plays out in different societies that are more highly vulnerable or less vulnerable, for example. How much does vulnerability make? Or how much difference does that make? Or so on. So last thing before we consider data needs is, on the next slide, the idea of actually already thinking about extending these. And the reason is that this framework, for the most part so far, has been developed at a pretty large scale and broad brush approach. These are global scenarios depicting broad trends in development for very large world regions. there's some national level quantitative information, right? But kind of the storyline, the narrative doesn't take place at the national level. It takes place at, 2, 3, 4 regions of the world. That's what's being described. And when you do a specific study, particularly for impacts, but also for mitigation, you're often going to need a lot more specific information to fill out detail in that scenario. That may be for a particular region, it might be for a sector, it may be for the whole world, but you just need more variables that aren't there yet. So this is an important piece of work going forward. There are a couple of things that have already been started that are in the works for extending these. If we go to the next slide, we have the first example of what that is. As I mentioned before, this is work actually we're doing at NCAR, where we have recently produced global gridded population projections for all of the SSPs. This is showing an example for Brazil. These are projections that are consistent with the national level population projections for the SSPs, but they downscale them to the grid cell level in some way consistent with the storyline. So for here, this is an example for SSP 5. On the left is the current population density distribution for Brazil. On the right is a projection for the end of the century that is consistent with SSP 5. And it's consistent in the sense that it produces the same total population as is envisioned for SSP 5. And in that scenario, part of the storyline is a qualitative description of development as concentrated, high urbanization. And so you see that reflected on the right, that population is not as spread out, it's concentrated in the cities. So these exist now. The paper hasn't been submitted yet, but the projections have been done for all 5 SSPs. On the next slide, not showing results, but just as a matter of information, the other variable that was considered really important was income distribution. Inequality was concluded to be a very important aspect of the SSPs because it was felt from the impacts and adaptation and vulnerability community that it was a very important determinant of all 3 of those things. So it's in the storylines, it's in there qualitatively, it's in there on a cross-country basis, but it was considered important to try to produce something quantitative at a subnational level. And so that's going on at the moment. There are a number of institutions involved in doing this work. We're doing some, we've been working with Landy some on this. There's a number of other institutions doing it as well. So that's coming down the road. But I can imagine you have thoughts in your mind of ways that you would need these scenarios to be extended to be useful to your work. And those are all things that we're looking for the research community to take an interest in and say, hey, that's useful, and we want to do that, and then to just go ahead and do it. Last, as I'll mention in extensions, there are some regional scenario development activities underway that are developing regional versions of these scenarios for the Arctic, for Europe. AgMIP refers to an agricultural model comparison project. That's a sectoral extension to look very much more carefully at agricultural outcomes. And we hope there will be more of these starting in the near future. So finally, I just wanted to say a few words. I know you're going to consider this in more detail throughout the day, and it sounds like from the introductions maybe in the afternoon as well, is what does this mean for thinking about information needs? So I want to just throw a few things on the table, first about demographic variables, second about economic. So as you can imagine from just the recent past couple slides that I showed, I think there's an important need for spatial information to be developed to help inform a lot of different kinds of impact and adaptation and vulnerability studies. This is potentially important on the emissions and drivers side as well, particularly for land use, but I think it's mostly important on the impact side. And we have a little experience with this simply as a result of this process of trying to produce spatial projections ourselves. The first thing you run into is while there are current data sets for the current distribution of population globally on a gridded level, there's actually a couple different data sets. What we don't have is consistent spatial data over time. So like in our case, if you have a model, you want to model spatial evolution, you want historical data to see how has spatial distribution evolved in the past so that you can see if your model works well or calibrate your model. And this is really difficult. The global data sets have some previous time periods, but they're not done in the same way as the current data set. So sometimes spatial distribution changes from one decade to the next, and it's simply due to methodological differences in the data set. It's not a real change in the real world. You can imagine that's not good information to provide a model with, because then your model is trying to reproduce definitional changes, and you don't want to be doing that. Equally important is that right now, we and others have only produced projections of numbers of people spatially. But as you all know, it's more important, often, characteristics of those people. In particular, their income, their education level, their age, probably other things you can think of. So for doing scenarios that quantify, what might that look like? How many people in cities exposed to heat waves might be in older age groups at low income levels, the most vulnerable types of people? Well, we don't have anything to inform that on a large scale, right? You can do it for an individual city here and there, but you can't do it at large scale. And data is a huge part of the problem for that. Similar issues for physical characteristics of the built landscape. We, but also others, have been looking at urban heat wave impacts, and you really need to know what buildings look like, what they're made of, how much of a city is tall building district or suburbs or slum. Migration, I think Landy will know a lot more about this than I personally, but it's something that we've been looking into also in Mexico in modeling migration, rural-urban migration, primarily internal migration for factors that influence future population distribution, so that we're often limited by data for really knowing where, for migration data, where did people come from, where did they go to, did they start or end up in an urban and rural place, and that can be difficult to get. Last, some similar themes on economic characteristics. In order to be able to consider fully the differential consequences of climate change or of climate change policy for different types of people, poor versus rich, or urban versus rural, or highly educated versus low educated, then we need data to go into those kinds of impact models. And the kind of data we rely on nationally representative household surveys that can tell us about expenditure patterns, about income and income sources, about savings and assets, about access to energy for looking at energy poverty issues, about participation in formal and informal economy, data on all of those things, not just those characteristics, but then the ability to quantify those characteristics for a number of subgroups of the population, so that we can define these separately for urban and rural and income levels and different education levels. And like in the population data case, some of the features that are important in the data sets are, you can do this for an individual country, but getting data that is consistent across countries and, again, over time, so that you can calibrate and validate models and look at historical trends, is difficult. And also the sheer difficulties in the practicality of doing this, of not only finding out which countries have such surveys, but getting access to them, being able to afford them, translating them, and getting assistance from people in those countries who know the data and the questionnaire and the instrument to be able to assist in the analysis. To be able to work together like this is difficult. So I'll end there. I hope that on the next slide is, if nothing else, the pretty picture again. But I hope by improving data and information that we can improve models and improve scenarios to have a better research base on these topics over the next several years. Thanks very much.